Now this section has 2 Dr. Bean videos. Again, they're live links. Go ahead and check them out. She says things more
because of the
quickly
law
than I
of
do.
constant composition,
So, and more
we know that
she can
that
say
is
something
carbon.
in a lot
Because
less
of the
time.
law of constant composition, we know that that is
You guys
carbon.
see? All right, so all those links, those work. They're like, I don't know, they're under 10 minutes. Each of those things are under 10 minutes. And if this explanation doesn't do it for you, and if what Dr. Bean is saying, if that doesn't work for you, Tyler DeWitt is great at explaining things in really, really like clear language with all the steps shown. And there's 2 different sets of videos for him. And then Melissa Marable is someone I discovered last year. And she's real current. The way she describes things, she uses a lot of pictures that are digital pictures. And I think that she does a very good job explaining things also. Okay, so scientific data. It's often used using percentage values. Now, this is true for percent composition, which is what we're about to talk about. And this is just a reminder, this is not new to you. Because y'all know I like to say non-political things, right? So non-political percentage calculations. You guys use these in real life. So usually at this point I would stop and I would say, what's a percentage you use in real life? Okay, so interestingly enough, one that pops up a whole lot is body mass index. Another one with the sports fans could be batting average. You can think of other things. I always throw out there that our grades are a percentage calculation. I just want to point out, percentages, you use them in real life. They give useful information to you, and they also give useful information to scientists. So that's why we use different kinds of percentages. This first type is percent composition. So we're basically going to be doing 3 different kinds of calculations. This is the first type, percent composition. And just a reminder, a percent, it's just the amount of something over all of it. I'm going to say part over the whole. I just want to let you know too, percent composition is like a subcategory of this word percent mass. So in Newton, if you see percent mass and you're trying to think of that, it's the same thing as percent composition. Yes, if the problem looks like the kind of problem we're working on, then yes, it's the same thing. Percent mass is like a bigger category, but different books use some different terminology. OpenStax uses percent composition. If you see Newton using percent mass, like send me a picture email and I'll message them. They've already fixed a few things they say they fixed a few things that I've asked about. All right, so percent composition, this is like any other percent. Remember, part over a whole. So this is just one type of element over the whole thing. Notice this is in grams and grams. Don't forget your times 100%. Don't forget to do that. So what is this saying? What does this mean? How on earth are you going to use it? It seems like kind of a weird formula. Okay, so it's actually really easy. So check out this problem and this will kind of explain it. So determine the percent composition of carbon in C6H12O6. What that means is that we want to know the total mass of carbon over the total mass of the molecule. And I know it's a molecule because it's just got the carbons, hydrogens, and oxygens in it. It's low key. In chemistry, we do things like, hey, assume 1 mole. Hey, assume 100 grams. You're going to hear both of those, and it's a great thing to use. So we're going to assume 1 mole of the compound, and it's going to help us cancel out one of our units if we do that. So following Dr. Shea's suggestion, we're trying to find the percent amount of carbon. So just remember, you're going to take the 6 moles. So see there's 6 of those. Oop, that is too dark. See how there's 6 of those though? Right there, there's 6 of those guys. That's why we use the 6 here. Because we're trying to figure out the total carbon weight. And then the 12.01 is just a number from the periodic chart. You look up carbon, that's the number you get. And if you add these guys all together from the periodic chart. Make sure you don't forget to multiply 12 for the hydrogen and 6 times oxygen. If you add that all up, you're going to get 180.18. So this is pretty easy. Just put it in your calculator. 6 times 12.01 divided by 180.18 times 100%. You're going to get 39.99. Now, just be aware that the sig figs for these things, and Dr. Bean says it this way, that they can be a little squishy. And what that means is that, our percent composition, these are kind of based on how good our instruments are at figuring out the composition. And we need to always make sure that our compositions add up to 100. So sometimes I'll round up to this position, even though it should be this position. To make it equal 100 properly. Here's the thing for you guys. It's not going to be a questionable situation for you. So if you get 39.99, it's going to work. If you get the 40.0, it's going to work. Like on a test, your answers, it's going to work out like that. So in general, keep to the right number sig figs. So keep to them. But if you ever see like an example problem somewhere where someone doesn't quite have the right number of sig figs, don't freak out. Because maybe the instrumentation they're using isn't great.